Good afternoon, everyone. My name is Cameron Presley, and I'm here today to chat with you about how you can level up on functional programming knowledge by building your own version of LINQ. Over the next 50 minutes, we are going to start from scratch, build up some of the concepts you're going to need to know to build up LINQ, and also some inspiration behind it, and how you yourself could have invented LINQ. No need to take any notes for today. All resources needed, so code samples, slide deck, everything can be found at the following bit.ly link. I'll make sure to include that as part of the chat in Teams, and Mel will help me out to make sure that this gets posted in the description on the YouTube video once it gets uploaded. So what are we going to be covering today? Well, we're first going to talk about what is LINQ. So what's the technology? How do we use it? Certain things like that. We're going to talk about some of the fundamental concepts on how to implement LINQ, and we'll go a little bit more detail. But this is kind of really the base, well, fundamentals that we have to understand in order to kind of derive LINQ ourselves. Once we've got those fundamentals in place, we'll actually implement the three most common LINQ methods. So this will be select, where, and aggregate. But this afternoon, we'll refer to them as map, filter, and reduce. So let's start with LINQ in general. So let's say I am writing some software to interact with delivery teams for a software company. So I've got this class, delivery team's got a name, someone as a team lead, and then some number of members. And then so I have a list of teams, right? Maybe alpha team, back to the code, skill overflow exception, and getting things done. And we have some various team lead names and some various member counts here. And let's say I wanted to know which delivery teams have more than 7 members. Well, one way I could do it would be to write the following code, where I've got a list called toLarge team names. I'm iterating through the list of teams, and if the member count's greater than 7, I'm adding it to that list, and then I'm going to return that list. Does anyone want to kind of volunteer, though, how much of this code is like actually business rules? What are the pieces of this code do we really care about, and the rest is just kind of has to be here as part of the machinery? The fun part about this is that there's really only 2 lines you as an engineer actually care about, and it's these 2 pieces. Everything else is actually noise. So the true business rules, the true things I'm going to make sure we're doing, are only in these 2 sections, but I have to write everything else to make that happen. Wouldn't it be a little bit more convenient if I could have written this code in such a way that made the business rules, the things that we care about, stand out a little bit more? And LINQ is a great way to do that. In fact, here's what it would have been in LINQ, where we'll do teams, and then we've got our business rules right here, front and center. A lot less boilerplate, a lot less for me to have to read, and the intent of what we're trying to do is a little bit clearer. And to me, this is one of the most powerful things about LINQ, right? It kind of shoves these rules up front and center and allows us to read that a little bit easier. And if we take a look at what LINQ is, right, from the docs, it says that LINQ is a set of operations that work on data that's independent of the source. And to me, that's really cool because it doesn't matter if it's coming from arrays or lists or if it's coming from a database or something. It's a set of operations that just work. And in addition, these operations are type safe, which means that this allows the compiler to catch your mistakes sooner. For those of you who attended my solid session earlier today, you will know that I'm kind of big in type safety and letting the compiler catch your mistakes at compile time instead of runtime. LINQ is a great way to start enforcing some of those things. So let's kind of dig in a little bit deeper and say, like, why do I like LINQ so much? Well, to me, this is kind of it, right? If you're an engineer and you're having to troubleshoot some code, I would probably want to troubleshoot the bottom code. To me, it's a lot easier to read, a lot easier to follow, a lot less things you have to debug through. But how does LINQ actually work, though? What are the 3 components you need to understand? The first component we're going to be talking about this afternoon is called Func, the Func data type, and how it's a little bit interesting compared to primitive types and even objects. We're also going to be looking into generics. Generics is one of the key functions that makes LINQ so extensible and able to work on so many different things. Last but not least, extension methods. This is how we can tie functionality onto things that we don't actually own. And we'll go into much more depth about each of these concepts in the following slides. So let's start with funcs. So funcs are really what they sound like. They're functions. They've been around for quite a while, since C# 3.0. And they are a type that you have to invoke them. But when they're invoked, they return a value. So this isn't like a string where, string is a string. You actually have to do something extra to actually be able to do anything with it. And funcs are also a little bit unique in that in order to invoke them, you need to pass in 0 or more parameters. So we're going to take the next couple minutes here and break down how to read func type signatures. That's kind of important. So if we have something known as a func of int, this means that it takes in 0 parameters, but will return an integer. And an example implementation is get number. Takes in 0 inputs, that's what the open close parenthesis means, and then returns 2. For those of you who do some digging in other functional languages, that open close parenthesis will also be typically referred to as a unit. This signature, on the other hand, func int comma string, tells us that it takes a number, some integer, and it's going to return a string. And a possible implementation may be toString, where you give us some number, we're going to give it back to you stringified as such. So once we get into more complex types like this, the last argument on the right is the return. Everything to the left is the inputs, and the inputs have to follow that order. And if we take a look at it a little bit more interesting of a function, we have the following. And this type signature tells us that it takes a number and a string, and it's going to return a new string. And so in this case, maybe it's called, we're going to write a function that knows how to repeat. So if you give me the number 5 and maybe the word hello, it's going to give me back a new string with 5 hellos in it. But as long as this type signature roughly makes sense to you, we actually have enough to start digging into how LINQ uses this. So let's go back to our LINQ example from before, where we're trying to find teams that have more than 7 members in them. Well, these things inside the parentheses, these are funcs. These are func data types. In this case, for the where, this is a func that says, given a delivery team, I need to return back a Boolean. And the second func here says, if you give me a team member, or a delivery team, excuse me, I'll give you back a string, its name. So if you've never thought about the func data type, but you've written LINQ before, now surprise, surprise, you've actually used funcs. You just may not have realized it. But let's go a little bit deeper. And so I know these are funcs so much that if I were to actually refactor and extract these out into the func data type, and so now I've given these funcs like real names, like more than 7 and get name, this code would compile, it'd still work. And to go deeper down the rabbit hole, I can even turn funcs into private methods like so, and this would still work as well. So, because at the end of the day, the private methods, so in this case, does team have more than 7 team members, it's still something that takes in a delivery team, returns back a Boolean. For those of you who were in my solid session earlier this morning, you will realize I like doing this extract method type functionality when things get a little more complicated. So not too bad. And we do the exact same thing for get team name. So, and for what we're discussing this afternoon, this is about the crash course in the funcs. Before we go into the next section on generics, are there any questions in the chat? All right, I'm not hearing any. No one's coming off mute, so we will keep going. So now that we've got funcs taken care of, let's go into generics, right? So cup of tea, if you will. So generics were introduced back in C# 2.0, so they've been around for a while. And generics are kind of cool because it allows you to parameterize your constructs now with types. The most common one that you've seen is the list type. And generics are awesome because sometimes you may have to write code that actually just works and the type doesn't matter for the implementation. That seems a bit weird, but let's dive into that a little bit more. So in C# especially, it's always easy to know if you're dealing with something that is working with generics because of the angle brackets. So list event, list string, list delivery team, even the func data type has generics. So if you see those angle brackets, you know that you're dealing with some type of construct that can be genericized. But let's see how this could come up in your normal day-to-day code. Let's say that for whatever reason, I'm having to implement a queue data structure, right? And so I've written a new class called number queue. It has a list of numbers because that's what we're backing it. And it's got a way to add numbers to the queue, and it's got a way to remove them from the queue with pop. But I don't know about you, sometimes I've got to write queues that work on other types. So for example, I have to now create a string queue. And like any good engineer, I copy and paste some code over, write some unit tests, make sure everything works. But then I start noticing that these two classes look really similar to one another. In fact, the only thing that's really different is the types. Okay. Well, if the types are the only thing that are different, maybe I can make this a little bit more general, a little bit more generic. So in this case, I've now created a generic queue class, and we know it's generic because I've kind of shoved these angle bracket t's. So now that I've defined t at the class level, when I instantiate a queue and specify its type, it will replace t with that type everywhere. But notice how we just kind of keep sprinkling them in as needed, and so far not so, so far so good. And to use the queue, be like this: a string queue would be new queue of string, and a number queue is a new queue of int, and everything would just kind of work along there. Generics are really awesome to help you reduce the amount of code you have to write, especially if types are more general. It always kind of surprises me that generics weren't in the first version of C#. But we've got them now, so we can totally leverage them. To me, right, when you're trying to figure out if you need to make something more generic, it's really when you're writing that third thing in a row, right? I'm a huge fan of patterns, but I don't want to refactor to a pattern. I want the pattern to kind of become apparent or visible first, then refactor to it. So if I'm writing the third structure and I'm like, man, this seems similar like the other two, maybe it's time to go ahead and do this refactor into a generic. Also, if the logic is pretty much the same, but only the types are different, that's the other clue that just putting straight generics would make some sense here. So I'm going to take another pause and see if there's any questions or anything in the chat we need to talk about. Okay, not seeing anything in the chat, so we'll keep it going. So at this point, we've learned a little bit about funcs. We've learned enough about funcs to be dangerous. We've learned enough about generics to be dangerous. It's time to talk a little bit about the third concept, which are extension methods. And extension methods are awesome because they allow you to tie into an existing type without owning it. This came out in C# 3.0. And so let's say that I wanted to add some functionality to some type that I got from a third-party library. I obviously don't have the source code to that third-party library, so I can't just hack it in there. Well, I can always extend it by creating this. And I'll show you how to do that with the built-in string type of .NET. So a good naming convention is the name of the type you're extending followed by extensions, and it needs to be a public static class. Once you've got that, we will create a public static method, has to be static, and it's going to take a parameter, and that parameter has to start with this, and that is the thing you're extending. So in this case, it'd be this string, and I could give it any name I wanted. I just chose S. But once we've got that, I can write some code here, and then as long as I return back a string, we're good, because that's the return type of capitalized in this case. So all this does is it just will return a string that's got the first letter capitalized. Maybe not the most performant thing in the world, but that's kind of not the point. But I can continue adding more extension methods. So this one does like some altering casing of the word here. But as long as I wrote this extension method, anywhere in my .NET code base now, I could do some string dot capitalize and that would work, or some string dot crazy case and that would work. But capitalize and crazy case aren't built into .NET. So extension methods are kind of cool to solve that problem. And here's the trick though. If you understand that you can now attach methods to things that you don't own, you understand how LINQ is going to work at a high level. And in fact, if you had all three of these concepts, you could have invented LINQ yourself. Could have totally done it. Would not have needed to come from Microsoft. Oh, and it's even funny, if you look at the docs on extension methods from Microsoft, it actually calls out that the most common extension methods are the LINQ standard query operators that query functionality to the IEnumerable type and IEnumerable of T. And you're already getting a hint that, hey, wait a minute, T, that's a generic. So extension methods and generics are somewhat related to one another. Yep, they sure are. So we've gotten to the point where we've covered some of the core concepts of what we needed for a foundation. Now it's time to actually start writing a little bit of code to implement LINQ ourselves. And to do that, we've got some guardrails and guidelines we're going to follow within. So if you look up the definition of LINQ, it actually works on anything that implements the IEnumerable interface. So that's what we're going to do too. We're going to extend onto the IEnumerable type. Some other guidelines we have is we're going to have the same signatures. So that means we're going to take in the same types as parameters for the things. So we saw where earlier, which said, give me a function of something that goes from input to Boolean. We'll follow that. Same thing for select, same thing for reduce. And also, we're going to talk a little bit about properties. This is one concept of LINQ a lot of people don't ever think about, but it's really kind of powerful because once you think about some of the guarantees you have with LINQ, all of a sudden your .NET code becomes a little bit more error-proof, which is kind of cool. So let's start with the first one. And in today's example, we're going to refer to it as map. That's what's used in a lot of other languages. In LINQ, it's really select, though. But what map does is it allows you to take a collection of one type of things and change it to a collection of another type of things using some type of mapping function. So select, or map in our case has one property, which is it maintains the length of the original collection. So if you call map on an empty list, you get back another empty list. If you call map on a list with 5 items, you are guaranteed to get back a list with 5 items, which is kind of cool in that regard. So let's see how we could have derived map just by some of the example code we wrote earlier. So once again, we've got our delivery team, right? Nothing interesting there. And now we say, hey, if I've got a collection of delivery teams, I want to see the names. So we go, all right, cool, we write some code. And we write some for each code that looks like this, right? We're going to iterate through the teams and grab the team name, add it to a list. Nothing too terribly complicated here yet. But we find that we keep writing this type of code all over the place, right? We seem to need to be able to do this in multiple places in the code. And because we want to reuse our code, right? We don't want to have 20 different ways to do the same thing. We actually turn this into an extension method. So we do our good diligence here. We create a new extension method class called delivery team list extensions. So it's got that public static class from before, and we've got the other things we need to do. And inside this method, we're doing kind of what we've been doing before, which is, list of team names, for each, all that fun stuff. So we've got some team names going on here. But now we find ourselves that, man, we've got a way to get team names, but now we need to see the team leads as well. Maybe we're writing some type of report. So we go, okay, cool. So we write some of that code, and then we go to thinking and go, man, we've got that extension class. Maybe we should tie into it. So we add a new extension method to that extension class called getTeamLeadNames. And it does something very similar where we iterate through the list of teams. We're getting the team lead from the team coming in and return the whole new list of those. But we're pretty sharp engineers. We take a look at the code we've written so far and we go, man, this code looks really similar to one another. If I ignore some of the naming, there's not really a whole heck of a lot of difference here. In fact, really the only difference we have is here. what are we adding to the list to return back? In some case, in the top case, it's just the name. In the bottom case, it's team lead. What if we could parameterize that a little bit? What if we could make some decision logic here and allow whoever was calling into this method choose what they wanted from team lead? All right. Well, we can do that, but we're going to have to create a new method. So we create a new one, and we're going to call it getStringValues. And it's still an extension method on delivery team, but it's got a new parameter. It's got this func that says, given delivery team, give me back a string. So we pass that as a parameter, and now that we have that, we can use that here. Now that we've got this working, we can actually go back and refactor get team names. So instead of doing all the logic before, we can say, hey, teams.getStringValues team.name, and we can refactor get team lead names to be very similar. And look at all the code we get rid of now, right? All the code that's common was old boilerplate that we can delete. So far so good. We've refactored some code, written some extension methods, not too bad. But now, as our business likes to do, they decide to give us a new requirement, right? And now they're like, man, we need to know the number of people on each team. So we go, all right, we know the song and dance. We create a new extension method called getTeamCount, and we can't use our extension methods that exist already because they only know how to work on strings. We're working with ints now. So we write this extension method code. It works, yay, shipped feature. But as engineers, we look at this code and go, oh goodness, these two things look really similar. In this example, I've already refactored it to use the same func trick we used before. So now we've got a way to get string values, we've got a way to get int values. But man, this code looks super similar. In fact, the only difference are the types. And if the types are the difference, then we can use generics. So we can actually refactor these two things to do something that looks like this, where we now have a function called map that says, if you give me a list of teams, and some function that says, given a team, I'll give you back something, whether it's a string or integer or whatever, I can go run this code. So we do that. And this is cool because now here's what gets cleaned up. Get int values and get string values are the exact same code now because of how types and generics work. So because of this, we actually don't need these two methods anymore at all. We can just remove them. That's pretty cool. Now, when we go back to get team names, get team lead names, and get team count, we can just use map. And that works out really well. But the question I have for the group here is there any reason why the map, right? Because we're attaching all this logic. Right now, the way we define map, it only works on a list of delivery teams. Is there any reason why we can only work on delivery teams? Could we make this a little bit more general? The answer to that question is, of course. We need to add a new generic type. So we go back to map, and we introduce a new generic for tSource now. So now how this code works is, if you give me some list, and a function that knows how to go from the type of that list to a new type, I now can stitch all this together. I now can convert. And so we get the following code. And that's pretty cool, because if you take a look on how select is implemented from like raw .NET source code, it's the following. Now, it's a little bit different because in the .NET world, there's a couple of different ways you can iterate through a list, and they have some performance tuning, so if they know it's a list, it goes a very particular way. But if you look at the implementation for select on GitHub when it's working with list, it's exactly this source code, which looks very similar to what we inferred, what we kind of derived here. And the fun part is it actually has to, right? For it to compile correctly and for it to maintain some of the qualities of you get back the same number of items, there's not too many different ways you could really write that. So to me, it's kind of cool that with us just kind of working through, some refactoring here, we came up with the same solution. That's pretty cool. So we're going to go one step further. Do we actually need to limit our extension method to only work on lists? The answer to that question is no. We can actually go one step further. We can use the IEnumerable type. Remember, that's actually what LINQ lives off of. It actually is an extension method off the IEnumerable. And so once you've got that, though, so we use an IEnumerable here. So then we just for each through every item in that IEnumerable. And then we do yield return. That yield return is what turns it back into an IEnumerable. So a little bit more general, and maybe not the world's most performant thing ever, because once again, Microsoft's done some performance tuning on their side. However, this would work. This would type check. This would do exactly what we claimed it would. And it follows all the principles of select. So we've covered quite a bit of stuff here in this one bit. So I'd like to take a moment and see if there are any questions, anything I need to elaborate a little bit more on. So feel free to throw that in chat or come off mute, either or. Making perfect sense. Because if it is, man, I'm doing a great job. Okay. All right. If there's no other questions, we'll keep moving then. So the big thing to know about map is you want to transform the data you have in your collection into the data that you need. That's why you would use map. That's why you'd use select. So the next common function we're going to implement is what I like to call keep. In .NET, you'll know this is where in functional programming in general, it's known as filter. I don't like that word because it's not always intuitive if you're filtering things in or filtering things out. I think Microsoft did a great job using where because it's pretty clear that you're keeping it. And so in our case, we'll use the word keep because we want to keep things that fit that criteria. So how keep works at a really high level is you've got a collection and you want to, well, keep some of it based on some type of predicate, right? Some type of criteria. But there's a lot of properties that keep has. One property you're guaranteed is that whatever you get back, it has to have a length between 0 and the original length. So if I run keep on a list of 5 items, I can't get back 10 items. It can't create something out of nothing. I can't get back a null either. That also won't work. So to me, that's pretty cool. It also can't give you back items that weren't in the original list. So for example, if I ran keep on a list of numbers 1 through 5, it can't give me 6. It can't give me 7. It can't give me something that wasn't in the original because once again, it cannot create something out of nothing. It also maintains order. So if I had a list of numbers once again from 1 to 5 and I wanted to keep the even numbers, I would get back 2 and 4, not 4 and 2. It actually maintains order. That's a lot of properties for just a single method out of LINQ. So you might think that there's a lot of logic we have to do to make this happen. And surprisingly, no, it's not too bad. Let me show you. So going back to our delivery team example again, right? We've got a new requirement that we want to figure out which delivery teams have more than 7 team members. So short-circuiting a lot of the logic we use for select, we end up with something like this, where we have a new extension method on an IEnumerable of delivery team. And what we do is we go through each team in that IEnumerable. If it has more than 7 people as a member count, we're going to return that team. So we've kind of got that logic going. But now we have a new requirement that we also want to do some code that says which delivery teams have Dana as a team lead. So once again, short-circuiting a little bit, we write a new extension method, very similar code. So now we've got these 2 extension methods, get teams that are too big and get teams led by Dana. And when we take a look at it, we go, huh, this code looks really familiar, right? It looks really similar to one another. In fact, really the only difference is this. It'd be kind of cool if we could parameterize that somehow. What technique do you think we could use to parameterize this that we've already talked about before?
Pass a function that returns a Boolean.
Yeah, exactly. Thank you. Yeah, we're going to add a new parameter to our getTeamsBy thing that we've created that takes in a predicate. Your fun fact of the day is the predicate is also a built-in type into .NET. It implies that it only has one parameter, but it implies that it returns a Boolean. So I'll keep it as func delivery team comma bool. And that's exactly right. So we pass it as an input, totally use it as that if check. This works, no problem. No issues, nothing there. Doing the same refactoring trick before, we can go back, update the getToBigTeams method to now be teams.getTeamsBy member count greater than 7. Same thing for getTeamsLedByDana. Same thing. All that code in green is now boilerplate. We can delete all of that, which is pretty cool. And we can actually go a little bit better. So this is our more general our more general extension method. And I ask the question again, is there any reason why we need to limit this to just delivery teams? No, right? We could actually make the delivery team type generic as well. And when we do that, we get code that looks a lot like this. So it's right. So everywhere we had delivery team, we could switch it out for this new generic thing called tsource, and that will all work. And it'll type check. And it has to, because since it's an IEnumerable of tsource, and that's the same type as the func needs to run its logic, it'll compile, it'll work just fine. Once again, it's a little bit interesting we come up with this solution, because if you take a look at the where implementation for .NET, once again, it's exactly the same. Once again, they've got some performance tuning on list versus arrays versus whatever, but it's still the same logic, right? Go through every item in the source. If the predicate returns true, return it back. And to me, it's pretty fascinating that through just making sure that the types align and we're following certain properties, we end up with the same implementation. And we kind of have to. Also, I find it really cool that for all those properties we talked about earlier, we didn't really have to write any interesting code to make that work. It just kind of worked out of the box. So at this point, if we know keep/where/filter is when you want to keep the data that you want. And if those two have made sense, the third one is kind of the piece de resistance. It's how do we go from a collection of many things to a single thing? And that thing is called reduce. In LINQ, it's known as aggregate, but in almost every other language, you'll find it as reduce, or fold is the other one you'll hear sometimes as well. But how this method works is that you've got a collection and some initial value. And then you are also handed something that knows how to combine the initial value with an item out of the collection. And once it does that, it returns back a single value. Seems really confusing. Let me give you an example. Let's say I wanted to sum up the numbers between 1 and 10. What I would do is I have to figure out what the initial value is when summing up numbers. That's 0, right? If I don't have any numbers in my list, then I've got 0. And then I had to define a function that knows how to take the initial value and an item out of my list and then return back a new integer. So in this case, it's just a plus b. And then to really work with aggregate, I get a range of numbers from 1 to 10. And then I aggregate over it starting at 0. And then for each element in the list, run the add function on it. So really the big thing is, right, you've got a collection of many things. You're trying to shrink it down to a single thing. You're going to use aggregate for that. So let's talk about how do we do this. So let's say we had a requirement to figure out, like, okay, how many team members do we have in total for our department? All right, cool. That's not too bad. We will create an extension method off delivery teams, call it total number of employees, int total equals 0. I'm going to iterate through each team in that list, add its member count, boom, return total. That's all we got. Not hard, not super really complex here. Maybe going to an extension method was a bit aggressive, but we would have gotten there anyway. And now let's say that we have a new requirement that we also want to grab the teams, all the team names. So we know that doing basic string concat's a bad idea, so we've got a string builder, and all we're going to do is we're going to add the every team name to that string builder and return back that string. So notice that it's not a list of names, it's a single string, right? String builder in this case. So on first blush, you take a look at this, this code doesn't really look the same, right? We've got string builders and ints, and we've got append lines and plus equals. Like, I can't parameterize on this like I could for select and where. It doesn't work that way, right? A basic func of, you know, given a delivery team, here's what I want. It's not quite appropriate anymore. I need a little bit more. But here's what these two methods do have in common. Some initial value, right? When we're adding up numbers, it's 0, but when we're building out this formatted team names, it's this new string builder with teams in the company, right? The next thing they both have in common is they have some way to combine what that initial value was with something out of the list. Because these two extension methods have those steps in common, we can actually combine these. Let me show you how. So really nasty type signature, I understand, we'll break it down. So we have to have some generic for the return type, because sometimes it's an integer, sometimes it's a string builder, therefore that's one generic. But now our reduce extension method says, all right, I'm going to live on delivery teams. You have to now give me some type of initial value. Once I've got that initial value, I also need a function that says, given that value and a delivery team, how would you give me a new thing of t result? And we're going to call that our reducer function. Once we have those pieces, though, our implementation is not too bad, because we say t result equals initial value. We iterate through the list of teams, call that reducer function now that says, given what we had before and team, here's the new thing. Run it through the rest of our list, and then return whatever the net result is. Once we have reduce working, we can refactor total number of employees, because now the initial value is 0. The reducer is now given a total and a team. Here's how I want you to update that. And then we can say return teams.reduce, initial value reducer. We get rid of all the boilerplate code we had before. And for formatted team names, something very similar. Initial value is that string builder. The function in this case for the reducer is something that says, given the string builder and the team, I want you to do a append line, and then we use reduce. So two things that looked like they had almost nothing in common from a type perspective actually becomes not too terribly bad to refactor down. The trick is realizing that there's a new generic type running around, and we now need both an initial value and this func. That's something a little bit different. So here is our just general reducer that we've been working on, and I get to ask the fun question, is there any reason why this would only work on delivery team? And no, it'd work on anything, right? Like we've kind of seen, all we would need to do is switch out the delivery team type to a T source, so a new generic, make those substitutions, and everything else would just work. So now you've got a reduce function that can work on anything that implements IEnumerable. So that's lists, arrays, dictionaries, all that fun stuff. And we kind of refined it over through refactoring it of just making it more generic when needed, passing in funcs when needed. And to me, that's really cool. If we take a look at the full aggregate solution from GitHub, once again from the .NET source code, And if you ignore the if checking, so making sure that you gave us a non-null for a source and a non-null in the func, it's exactly the same code, right? Just switch out t accumulate for t result, and then you've got it, right? They grab whatever the initial value is, iterate through the IEnumerable, call func on it, and then return that result. Once again, I find it really cool that we can refactor to what they wrote. And we had to because everything's got a type check. The compiler wouldn't allow us to compile the code otherwise. How are we doing at this point? Either I've done the world's best job in explaining this, in which case maybe I need to change my profession, or maybe people are still chewing through lunch. Maybe that's what's going on. And that's okay if that's the case too. Someone asked in the chat, are the slides be available? Yes. I haven't. I'll post the link into it. If you're coming in late, there was a slide at the very beginning that said you can find everything you needed at a very particular URL. In fact, let me see if I can help out a little bit here real quick. A little bit bigger than I'm intending, but that'll help you out. Okay.
Are you screaming?
No, it was what was in my clipboard. My apologies.
Kidding.
No, it's all right. No, I'm just super excited about this topic. Just super passionate. Just screaming out into the void at times. But if things have made sense at this point, I'm going to blow your minds a little bit. But let's finish this out. So the big reason that you're going to want to use reduce is when you want to change a collection, when you want to go from a collection down to a single value. If you're going to do that, you got to figure out what the initial value is, and then you need to write that reducer function. But if you can do those two things, you can use reduce. But here's where I may have tricked you a little bit. What if I told you we can actually rewrite all of the LINQ that we've written so far to only use reduce? Say, what? No, seriously, we can do it, and it's actually not that bad of an exercise. So if you travel in functional programming circles, you'll hear that reduce is kind of like a universal function, that you can use reduce to model all these other things, and it's actually true. So let me show you. So if we're going to refactor map and keep to use reduce, we've got to figure out the two things, right? First one is what's the initial value, and then how do we combine that initial value with the next element? If we can figure those two things out, we can refactor to use reduce. So as a reminder, here's what map looked like before. So the question we have now is, what's the initial value? What should we return if the source is empty? So you may, if you think back to our properties, you know, we said that select always, or select and map, they always give you back a collection that was the same size. So if I've got an empty, what should I return?
Empty.
Yeah, got to return something that's empty. I'm going to cheat a little bit, and I'm going to use something out of the enumerable library that's called literally .empty that does that. You can write your own helper function to do this if you didn't want to use that library at all. That's okay. But I'm going to cheat because y'all don't want to see that code. But we're going to use enumerable of tresult.empty. So now that we have that, we can actually stub out what map would look like using reduce. So we know the signature has to stay the same, right? Given a source and a selector. But what's interesting is we know what a return's got to look like. We know it's got to be return source.reduce, initial value, which is empty, followed by the reducer now. The trick is going to be, what is the reducer going to look like? However, we know what the data types have to be. They have to be the following. So it's got to be a function that says, given an IEnumerable of t results and a t, I need to give you back a new IEnumerable of t result. And then we're going to call the first parameter values and the second parameter item. So if we can figure out the guts, right, the guts of the reducer function, we've got it. So we need to figure out a way to convert the item, which is currently of type T, to a T result. And then once we've done that, we've got to append it to values. So out of curiosity, can anyone spot a way where we could convert that item from a T to a T result?
Call the selector function.
Bingo. Absolutely. Yeah, so we can actually use that selector function, right? So we've now got T result of converted item. No problem there. Pass, because we already have that in here. So no problems there. And then we need a way to append the value. And to do that, this is where I'm cheating and using that enumerable library, just using values.append. Under the hood, what it would do is it would for each through every item and yield what was in values. And then once it yielded through all of that, it would then yield converted item. You all don't want to see that code. It's kind of not important. But the big thing is we have a way to append it. But once we have this return in here, it all type checks. It'll all work. And is this code as easy to follow as the original map? I would argue no, maybe not. But could we do it? Heck yeah. Oh, absolutely. So I think that's pretty cool. So we've got map down. Let's talk about keep. So remember, this is what keep source code looked like originally. So we've got the same two questions. What's the initial value? And what should we return what's the initial value? And then how do we write the reducer? For our initial value, it's really the same question we had before. What do we return if we were running on an empty source? And in this case, we're going to use empty again. So we know what our initial value is. Because we know our initial value, I can plop in some boilerplate code here and that'll work just fine. So now we're back to our reducer function. And our reducer in this case says, all right, well, we've got an IEnumerable of T called values, and we've got some item from the original source of things called item. I've got to figure out a way to return you back an IEnumerable of T. So the questions we've got here is we need a way to check to see if the item meets the criteria, so if we should keep it or not. And then if it does meet that criteria, we need to append it to values. So once again, what function or what thing do you think we could use to check to see if item meets the criteria? We can use the predicate, right? Because it's already being passed in as part of keep. So now that we've got that, we can say if predicate item, we're going to run some logic. Otherwise, because that's important, we still have to return back some IEnumerable if the predicate's not met. So, here we go. We've added that code section. And we're actually just going to use append. So if the item passes the predicate, cool, we do values.append. And if it doesn't, no problem. Here's your values back. We didn't make any changes to it. And just like that, we've refactored keep to be implemented via reduce. Once again, is it as readable as keep was originally? No, absolutely not. Am I telling you to go rewrite this stuff in reduce? Absolutely not. Is it a good exercise to learn how all this stuff hangs together? Absolutely it is. For those playing along at home, a really good exercise is trying to implement some of the other LINQ methods. Like first or default, singular default, group by is particularly fun. So yeah, absolutely. Well, at this point, what did we actually cover today? Because we've covered a whole bunch. We talked about LINQ, kind of at a really high level what it is. We talked about some fundamental concepts that you need to understand for really LINQ to have worked, which was funcs, generics, and extension methods. And then we actually implemented some of these things, right? We implemented map, keep, reduce, and we even went one step further and re-implemented map and keep using just reduce. That's a whole bunch of stuff in like 55 minutes, which is pretty cool. But in case you didn't cut, all this didn't click, it's like, wow, there's a lot of stuff here, Cameron. some takeaways I want you to have is LINQ's not magic, right? If it's not magic, we actually built out some of it in literally 50 minutes. All it is just a composition of core concepts, funcs, generics, and extension methods that allows us to build bigger programs from smaller programs. And you saw that happen throughout, right? Where we took some code, refactored it, made it a little bit more general, took some code, refactored it to make it a little more general, and then started composing. So with that being said, thank you so much, y'all, for letting me speak to you this afternoon at Philly Code Camp. If you have questions, feel free to always send them to me at my email at cameron@softwarementor.com. And as requested in the chat, here is a link to not only the slide deck, but all the other resources you need. So code samples, everything, even references to where to find stuff on GitHub. But with that being said, thank you all so very much. I appreciate being here.
Thank you.
Yeah. I'll say I also know we're on a somewhat tight schedule because I think the 1 o'clock sessions are going to start soon. So I wanted to make sure you all had time to get to those too.